Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 21 Trigonometric Identities. We'll be discussing Exercise 21B. We have already discussed in our previous video trigonometric ratios, the relation between the trigonometric ratios and the trigonometric identities, using which we will be solving questions from Exercise 21B today. First example. Cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A is equal to cos A plus sin A. Okay. Here LHS we have cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A. And RHS is cos A plus sin A. Let's start with the LHS. LHS is equal to cos A divided by 1 minus tan A plus sin A divided by 1 minus cot A. We have solved similar examples in our previous session. Here tan A and cot A we are going to write in terms of sin and cos. Then this becomes cos A divided by 1 minus. What is tan? Tan is sin by cos. Sin A by cos A. Here we have sin A divided by 1 minus. What is cot A? Cot A is cos A by sin A. Cos A divided by sin A. Okay. Now consider this denominator parts. Here we have cos A divided by. Here we have a 1 taking LCM. 1 into cos A is cos A. Now cross multiplying. 1 into cos A minus sin A into 1 which is sin A. Okay, similarly here numerator will be having sin A, denominator again. Here in the denominator it is 1 and sin A, LCM sin A. Numerator of this part sin A minus cos A into 1 is cos A. Okay, next taking the reciprocal and multiplying we get cos A into cos A divided by cos A minus sin A plus sin A into sin A divided by sin A minus cos A. Okay, what is cos A into cos A? Cos A into cos A we get cos square A. That is equal to cos square A divided by cos A minus sin A plus sin A into sin A is sin square A. Sin square A divided by sin A minus cos A. Okay. But making the common denominator, here we have cos A minus sin A. Here it is sin A minus cos A. Sin A minus cos A can be written as minus of cos A minus sin A. Okay, sin A minus cos A is minus of cos A minus sin A. Minus cos A, minus of minus becomes plus which is sin A. That is sin A minus cos A. Here we are going to change this denominator into minus of cos A minus sin A. Then we get cos square A divided by cos A minus sin A. Then we have a plus sign here. Plus in the denominator we will be getting minus of cos A minus sin A, which means we can take that negative sign to the numerator. Minus sin square A divided by cos A minus sin A. Okay. Now the denominator is same. That is cos A minus sin A. Numerator, here we have cos square A plus and minus, plus into minus is minus sin square A. This is of the form A square minus B square, which is A plus B into A minus B. Therefore, cos square A minus sin square A becomes cos A plus sin A into cos A minus sin A divided by cos A minus sin A. Okay. We can cancel this cos A minus sin A from numerator and denominator. Then we are having cos A plus sin A. Okay. This is what we need. Here RHS is cos A plus sin A. So we have reached RHS. From LHS we have solved to get RHS. This is the required proof. Hence proved. Okay, next example. 1 plus tan square A plus 1 plus 1 by tan square A is equal to 1 by sin square A minus sin raised to 4A. That is, RHS is in terms of sin. We have to convert this into the form of sin. Okay, so let's start. Left hand side we have 1 plus tan square A plus 1 plus 1 by tan square A. That is equal to, here what is 1 plus tan square A? We have studied an identity. Sec square A is equal to 1 plus tan square A. So we are substituting this identity here. In place of 1 plus tan square A, we can write sec square A. Sec square A plus 1 plus 1 by tan square A. That is 1 plus 1 by tan square A. 1 by tan square A is cot square A. Okay. Sec square A plus 1 plus cot square A. What is 1 plus cot square A? Cosec square A. Therefore, you get sec square A plus cosec square A. Now, we have to bring this in terms of sine. So, what can be done? The sec square A can be converted into 1 by cos square A. Okay, we know sec is the reciprocal of cos. Therefore, sec square A will be equal to 1 by cos square A. Plus, what about cosec square A? Cosec square A is 1 by sin square A, since cosec is the reciprocal of sine. Okay, so you have 1 by cos square A plus 1 by sin square A. Now, taking LCM, we get cos square A is the denominator here, and here it is sin square A. There is nothing in common, therefore denominator you will be getting cos square A sin square A. Now cross multiplying, 1 into sin square A plus 1 into cos square A is cos square A. Okay. Now what is sin square A plus cos square A? You will be having sin square A plus cos square A is equal to 1, which is the required identity. Okay. Divided by cos square A sin square A. Here we have used the identity. Sin square A plus cos square A is equal to 1. Now what can be done? Numerator is okay. Here the numerator is 1 and here we have got the numerator 1. What about denominator? Denominator is completely in terms of sine. We have cos. So we have to remove this cos. For that what can be done? Since sin square A plus cos square A is equal to 1, we will be having cos square A equal to 1 minus sin square A, which can be substituted here. We get 1 by 1 minus sin square A into sin square A. Okay, that is equal to 1 by, removing the brackets and multiplying, 1 into sin square A is sin square A minus, what is sin square A into sin square A? Sin raised to 4A. Sin raised to 4A. So 1 by sin square A minus sin raised to 4A. Here this is the same thing in the RHS. So this is equal to RHS and this is a required proof. Hence proved. Okay, so we have to check this. Here what is there in the RHS? RHS is fully in terms of sine. So when you start, you should have in the mind that at the end you should get something in terms of sine. Okay, so sine is related to cos, sine is related to tan, sine is related to cosec. Yes, so if you have in terms of tan, cosec, etc., you will have to bring it in terms of sine. Clear? Third example, if x is equal to a sec a cos b, y is equal to b sec a sin b, and z is equal to c tan a, show that x square by a square plus y square by b square minus z square by c square is equal to 1. Here x is given, y is given and z is given. Okay, we are going to put this values of x, y and z in this equation. Okay, take the left hand side part of the equation LHS. We have x square by a square plus y square by b square minus z square divided by c square. Okay, now put the value of x. What is x? X is equal to a sec a cos b whole square divided by a square plus what is y? Y is equal to b sec a sin b whole square divided by b square, and then z is c tan a minus c tan a whole square divided by c square. Okay, now here we get a square sec square a cos square b divided by a square plus here again whole square becomes b square sec square a sin square b divided by b square minus c square tan square a divided by c square. You can cancel this a squares, b square and c square. Okay, then what is remaining? Here we are having sec square a cos square b, which means you can take sec square a cos square b plus sec square a sin square b minus tan square a. Now what is common in both these terms? Here we have sec square a, here also we have sec square a, which means sec square a can be taken outside. Sec square a into, here we have cos square b remaining and here we have sin square b remaining plus sin square b minus tan square a. Okay, sin square b plus cos square b. Using the identity, we will be having sin square b plus cos square b equal to 1. Then you have sec square a into 1 minus tan square a. Okay, sec square a into 1 is sec square a minus tan square a. What is sec square a minus tan square a? We have studied an identity. Sec square a is equal to 1 plus tan square a. From this identity, using this identity, we will be getting sec square a minus tan square a is equal to 1. Just shifting this tan square a to the opposite side, we get sec square a minus tan square a is equal to 1. Okay. Now here we have sec square a minus tan square a and that is equal to 1, which is the RHS. So this is the required proof. Clear? Okay, so here we have used the identity sec square a is equal to 1 plus tan square a, and here we had sin square b plus cos square b and that is equal to 1. Example 4, this is from your revision set. Here we have to prove that cos square a plus tan square a minus 1 divided by sin square a is equal to tan square a. Let's start from the left hand side. Left hand side we have cos square a plus tan square a minus 1 divided by sin square a. Okay. Now this can be written as cos square a divided by sin square a plus tan square a divided by sin square a minus 1 by sin square a. What is cos square a divided by sin square a? Cos a by sin a is equal to cot a. Therefore, cos square a divided by sin square a will be equal to cot square a. Cot square a plus. Now here we have tan square a, which is sin square a divided by cos square a. Okay. Here denominator is sin square a. Sin square a divided by 1. Taking reciprocal, we get 1 by sine square A minus 1 by sine square A. Okay, here from numerator and denominator we can cancel sine square A. Then we have cot square A plus, what is 1 by cos square A? 1 by cos square A is equal to sec square A minus 1 by sine square A is cosec square A. Okay, what is cot square A? We have a relation 1 plus cot square A is equal to cosec square A. This is an identity we have studied. Okay, from this we can write cot square A is equal to cosec square A minus 1. Okay, we are using this identity 1 plus cot square A is equal to cosec square A, from which cot square A is equal to cosec square A minus 1. Here we have a cot square A. I am going to substitute cosec square A minus 1. Cosec square A minus 1 plus sec square A minus cosec square A. Now here, check the right hand side. What is there in the right hand side? We need tan square A. We need a relation which gives us tan square A. Here we have cosec square A and minus cosec square A, which can be cancelled. Then the remaining is sec square A minus 1. Okay, left hand side we got sec square A minus 1. How is sec square related to tan square? We have a relation 1 plus tan square A is equal to sec square A. If 1 plus tan square A is equal to sec square A, we can write tan square A is equal to sec square A minus 1. Okay, so this is the second identity that we are using. 1 plus tan square A is equal to sec square A. Therefore, tan square A is equal to sec square A minus 1, which will be putting here. Therefore, LHS we are getting tan square A. Since sec square A minus 1 is equal to tan square A. What is RHS? RHS is also equal to tan square A. Therefore, we got LHS and RHS equal. This is the required proof. Hence proved. Clear? So we are using two identities here. 1 plus cot square A is equal to cosec square A and 1 plus tan square A is equal to sec square. Okay, next example 5. We have to prove that sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1 is equal to 1 by sec theta minus tan theta. This is a question from your revision set. Let's start. Here LHS we have sin theta minus cos theta plus 1 divided by sin theta plus cos theta minus 1. Okay, so the first step what we are going to do is, here we have sec and tan. Yes, so we have to get in terms of sec and tan. So the sin, cos, etc. should be changed to sec tan form. Now for that what I am doing is I am dividing throughout with cos theta. Dividing throughout with cos theta. Then what do we get? Sin theta by cos theta minus cos theta by cos theta plus 1 by cos theta. Okay. Now the denominator part, sin theta by cos theta plus cos theta by cos theta minus 1 by cos theta. Okay. Here what is sin theta by cos theta? Sin theta by cos theta is tan theta. Tan theta minus cos theta by cos theta is 1 plus 1 by cos theta is sec theta. Divided by, here again sin theta by cos theta is tan theta plus cos theta by cos theta is 1 minus 1 by cos theta is sec theta. So next step we are going to multiply the numerator and denominator with the term. Okay, let's see what the term is. Here we have tan theta and minus sec theta. So from this part we are taking tan theta minus sec theta and multiplying it with the numerator and denominator. Okay, tan theta minus 1 plus sec theta divided by tan theta plus 1 minus sec theta into tan theta minus sec theta divided by tan theta minus sec theta. Okay. So now this can be written as tan theta plus sec theta minus 1 into tan theta minus sec theta divided by tan theta minus sec theta plus 1 into tan theta minus sec theta. Okay. Now here we have tan theta plus sec theta and this is tan theta minus sec theta. Now removing the brackets and multiplying, we get tan theta plus sec theta into tan theta minus sec theta. This is one term. And the next term, here we have a minus 1. 1 into tan theta minus sec theta. Okay. Denominator same, we have tan theta minus sec theta plus 1 into tan theta minus sec theta. Okay. Here a plus b into a minus b form. In place of a we have tan theta and in place of b it is sec theta. A plus b into a minus b is a square minus b square. So we get tan square theta minus sec square theta. Here we have a minus 1 into tan theta minus sec theta divided by same thing, that is tan theta minus sec theta plus 1 into tan theta minus sec theta. Now what is tan square theta minus sec square theta? We have 1 plus tan square theta is equal to sec square theta, which means sec square theta minus tan square theta will be equal to 1. What about tan square theta minus sec square theta? Here we keep the tan square theta and bring this sec square theta to the left hand side. So minus sec square theta will be equal to, this 1 goes to right hand side, plus 1 becomes minus 1. Okay. So this part we get minus 1. Minus 1, removing the bracket, minus tan theta minus of minus 1 into minus sec theta is plus sec theta. Plus sec theta divided by, what about denominator? Denominator we have tan theta minus sec theta plus 1 into tan theta minus sec theta. Okay. Here we have tan theta minus sec theta plus 1 in the denominator, minus 1 minus tan theta plus sec theta in the numerator. How can you cancel this? If I remove a negative sign from the numerator, I can cancel this. Okay. This is equal to minus 1 into 1 plus tan theta minus sec theta. Okay. In order to cancel these two terms, I am taking the negative sign outside. Then we have denominator tan theta minus sec theta plus 1 into tan theta minus sec theta. Now cancelling these two, we get 1 plus tan theta minus sec theta gets cancelled. Minus 1 divided by tan theta minus sec theta. What do we have in the right hand side? It is 1 by sec theta minus tan theta. This can be written as 1 by minus 1 into tan theta minus sec theta. Okay, negative sign usually we don't keep in the denominator and we take it to the numerator. Now in order to rearrange this, I am taking this negative sign to the denominator. Then we get 1 by minus tan theta minus of minus plus sec theta. Or this is equal to 1 by sec theta minus tan theta. So this is the required right hand side and we have proved. Clear? So this was somewhat lengthy. You have to remember the steps that we have done, especially this step where we have multiplied tan theta minus sec theta. with the numerator and denominator. This has been done because only then we can get this form, that is tan square theta minus sec square theta, which can be made 1. So usually we have to arrange in such a way that we can apply the identity to reduce the equation. Okay. To reduce the equation, we should get 1 somewhere. Yes. To get 1, we have 3 identities that we have studied. So try to use those identities. Okay. Example 6. This is also a question from the revision set. Prove that sin A into 1 plus tan A plus cos A into 1 plus cot A is equal to sec A plus cosec A. Here LHS we have sin A into 1 plus tan A plus cos A into 1 plus cot A. That is equal to, here sin A into 1 plus tan A can be written as sin A by cos A. Sin A by cos A. So our aim is to bring this in terms of sec and cosec. Plus cos A into 1 plus cot A can be written as cos A divided by sin A. Okay. Now removing the brackets and multiplying, sin A into 1 is sin A plus sin A into sin A by cos A, sin square A divided by cos A plus cos A into 1 is cos A plus cos A into cos A divided by sin A is cos square A divided by sin A. Okay. Now I am making a small rearrangement. I'll write sin A plus cos square A divided by sin A plus sin square A divided by cos A plus cos A. Okay. Now our aim is, when I take this sin A here and we have a sin A here, by taking LCM, we'll be getting sin square A in the numerator plus cos square A, so that it becomes equal to 1. So that is our aim. For that we have made this rearrangement. Then we get sin A as LCM, because here the denominator is 1. Sin A into sin A is sin square A plus cos square A into 1 is cos square A plus, what about here? What is the denominator? In this case, cos A divided by 1, LCM when taken, we get cos A. Numerator, sin square A into 1, sin square A plus cos A into cos A is cos square A. Okay. Sin square A plus cos square A is equal to 1. 1 divided by sin A plus sin square A plus cos square A is again 1 divided by cos A. What is there in the RHS? RHS we need sec A plus cosec A. This is cosec A and this is sec A. 1 by sin A is cosec A plus 1 by cos A sec A. That is equal to sec A plus cosec A, which is the required RHS. So we have proved sin A into 1 plus tan A plus cos A into 1 plus cot A is equal to sec A plus cosec A. Hence proved. Okay. Now let us solve problems from exercise 21B. Here we have the first problem, question 1. Sub-question 5 of exercise 21B. Prove that 2 sin square A plus cos raised to 4A is equal to 1 plus sin raised to 4A. Here LHS you have sin and cos, RHS you have only sin, which means you have to convert this whole in terms of sin. LHS is equal to 2 sin square A plus cos raised to 4A. Now, this is equal to 2 sin square A plus cos raised to 4. What do we do when raised to 4 power comes? We used to make it square of square. Same thing we are doing here. Cos square A whole square. Okay. Now, using the identity, that is square A plus cos square A is equal to 1 we'll be having cos square A is equal to 1 minus sin square A. We need to convert it completely in terms of sine. Okay. So cos square A can be related to sin square A. Cos square A is equal to 1 minus sin square A. Now substituting, we get 2 sin square A plus 1 minus sin square A whole square. That is 2 sin square A plus A minus B whole square. A minus B whole square is A square minus 2AB plus B square. Here in place of A we have 1 and in place of B it is sin square A. 1 square minus 2AB. 2 sin square A plus B square. What is B square? Sin square A whole square. Sin raised to 4A. Okay. So that is 2 sin square A. Removing the brackets, we get plus 1 minus 2 sin square A plus sin raised to 4A. Now from this, 2 sin square A minus 2 sin square A can be cancelled. We have 2 sin square A and minus 2 sin square A. What is remaining then? We have 1 plus sin raised to 4A. Okay. This is the RHS. So we started from left hand side. In left hand side we had sine and cos terms. We had to bring to right hand side which is only in terms of sine. For that we are changing this cos square A term. Okay. So this is RHS. Hence proved. Clear? Next problem. Question number 1. Sub-question 8 of exercise 21B. Prove that 1 plus tan A into tan B whole square plus tan A minus tan B whole square is equal to sec square A into sec square B. So here RHS is in terms of sec and LHS is in terms of tan. We have to convert this tan to sec. Taking LHS, we have 1 plus tan A tan B whole square plus tan A minus tan B whole square. That is equal to 1 plus tan A tan B whole square. This is of the form A plus B whole square. Tan A minus tan B whole square is A minus B whole square. So applying the formulas, 1 plus tan A tan B whole square will be 1 plus 2 tan A tan B plus tan A tan B whole square is tan square A tan square B plus tan A minus tan B whole square will be equal to tan square A minus 2 tan A tan B plus tan square B. Here we have used A plus B whole square is equal to A square plus 2AB plus B square and A minus B whole square is equal to A square minus 2AB plus B square. Okay. Now 2 tan A tan B can be cancelled because you have 2 tan A tan B and minus 2 tan A tan B. What is remaining here? We have 1 plus tan square A tan square B plus tan square A plus tan square B. That is equal to 1 plus tan square A plus tan square A tan square B plus tan square B. Okay. Now what is 1 plus tan square A? We have studied an identity. Sec square A is equal to 1 plus tan square A. Therefore here we get sec square A. Okay. This is how we can relate tan and sec. Plus here we have tan square A tan square B and again a tan square B. Now tan square B can be taken out. Tan square B into remaining we have tan square A plus 1. Okay. From this part, if you take tan square B outside, then 1 is remaining. Now, what is 1 plus tan square A? 1 plus tan square A is equal to sec square A. Yes, we get sec square A plus tan square b into again sec square a. Now the sec square a is common. Sec square a can be taken out. Sec square a into 1 plus tan square b. What is 1 plus tan square b? 1 plus tan square b is sec square b. This is equal to sec square a sec square b, and which is the required RHS. Okay. So from LHS, which was in terms of tan, we have reached RHS, which is in terms of sec. Hence proved. Okay. Next, problem number 3, question 2 of exercise 21b. If x cos a plus y sin a is equal to m and x sin a minus y cos a is equal to n, then prove that x square plus y square is equal to m square plus n square. Okay. Here we know what m is and what n is. So first we'll take the RHS. RHS we have m square plus n square. Okay. Now what is m? M is equal to x cos a plus y sin a. Substitute x cos a plus y sin a whole square plus what is n? N is equal to x sin a minus y cos a whole square. Okay. Now this is of the form a plus b whole square, and this is a minus b whole square. A plus b whole square is equal to a square plus 2ab plus b square equal to x square cos square a plus 2xy cos a sin a plus y square sin square a. Okay. Now this one, x square sin square a minus 2xy sin a cos a plus y square cos square a. Now here we have 2xy cos a sin a and minus 2xy sin a cos a. They can be cancelled. Same term, one is positive and the other is negative. Now x square containing terms, x square cos square a plus you have x square sin square a. X square sin square a. Similarly, y containing terms, y square sin square a plus y square cos square a. From this we can take x square out. X square into sin square a plus cos square a. Similarly, from here we can take y square out plus y square into sin square a plus cos square a. Now using the identity, we have sin square a plus cos square a is equal to 1. Okay. Here we have sin square a plus cos square a. Similarly, here also we have sin square a plus cos square a. Putting 1, we get x square plus y square, which is the left hand side. Therefore, x square plus y square is equal to m square plus n square. This is the required proof. Next problem 4, question 3 of exercise 21b. This is a question that is similar to the previous one. There we had sin and cos. Here we have sec and tan. Okay. If m is equal to a sec plus b tan a and n is equal to a tan a plus b sec a, then prove that m square minus n square is equal to a square minus b square. Here we'll be starting from LHS. LHS we have m square minus n square. What is m? M is equal to a sec plus b tan a. A sec a plus b tan a whole square minus n a tan a plus b sec a whole square. Okay. M square minus n square. Same procedures. Here it is a plus b whole square. Here again a plus b whole square. A plus b whole square is equal to a square plus 2ab plus b square. We get a square sec square a plus 2ab sec A tan A plus B square tan square A minus, here we have A square tan square A plus 2AB, and distributing this negative sign, we get A square sec square A plus 2AB sec A tan A plus B square tan square A minus A square tan square A minus 2AB tan A sec A minus B square sec square A. Okay. Now here we have plus 2AB sec A tan A. Here we have minus 2AB tan A sec A, which can be cancelled. Now A square containing terms, we have A square sec square A minus A square tan square A. Now B containing terms, plus B square tan square A minus B square sec square A. Okay. From this A square can be taken out. A square into sec square A minus tan square A. From this B square can be taken out. Here I am taking minus B square out. Okay. When minus B square is taken out, we get sec square A minus tan square A. Just to get the same terms here, we can take minus B square outside. Okay. Now sec square A minus tan square A. What is sec square A minus tan square A? We have an identity. Sec square A is equal to 1 plus tan square A. If sec square A is equal to 1 plus tan square A, then sec square A minus tan square A is equal to 1. So we are applying this identity here. We get A square into 1 minus B square into 1, and that is equal to A square minus B square. We started from M square minus N square and got A square minus B square. Therefore, M square minus N square is equal to A square minus B square. Okay. Problem number 5, question 4 of exercise 21B. If x is equal to r sin A cos B and y is equal to r sin A sin B, z is equal to r cos A, then prove that x square plus y square plus z square is equal to r square. Okay, here we have x, y and z given. We have to show that x square plus y square plus z square is equal to r square. What is x square plus y square plus z square? Starting from the LHS, x square plus y square plus z square is equal to r sin A cos B whole square plus, next y square is r sin A sin B whole square plus z square is r cos A whole square. That is equal to, distributing the square, we get r square sin square A cos square B plus, here r square sin square A sin square B plus, here it is r square cos square A. Okay. Now from this we can take r square sin square A common. We get r square sin square A into cos square B plus sin square B plus, remaining we have an r square cos square A. Okay. Now r square sin square A. What is cos square B plus sin square B? Cos square B plus sin square B will be equal to 1 using the identity, plus r square cos square A. Now what can be done? R square is common in both the terms. R square is taken out. Then here we have sin square A and here we have cos square A. Sin square A plus cos square A. Again, what is sin square A plus cos square A? Using the identity, we have sin square A plus cos square A is equal to 1. 1 into r square. So we got x square plus y square plus z square is equal to r square, which is the RHS. Okay, x square plus y square plus z square is equal to RS. Okay, problem number 6, question 5 of exercise 21B. If sin A plus cos A is equal to m and sec A plus cosec A is equal to n, show that n into m square minus 1 is equal to 2m. Okay, n into m square minus 1 is our LHS. LHS is n into m square minus 1. Now put the values of n and m. Here n is equal to sec A plus cosec A into m square. M square is sin A plus cos A whole square minus 1. Okay, that is equal to sec A plus cosec A into sin A plus cos A whole square is sin square A plus 2 sin A cos A plus cos square A minus 1. Okay, now we have sin square A plus cos square A. What is sin square A plus cos square A? That is also equal to 1. Therefore, sec A plus cosec A into 1 plus 2 sin A cos A minus 1. Sin square A plus cos square A is equal to 1, and here we have a minus 1. 1 minus 1 removed, then we have sec A plus cosec A into 2 sin A cos A. Now sec A and cosec A we are going to convert in terms of sin and cos. What is sec A? Sec A will be 1 by cos A plus cosec A is 1 by sin A into 2 sin A cos A. 2 sin A cos A. Now taking LCM, denominator we get sin A cos A. Numerator, here we have cos A. 1 into sin A is sin A plus 1 into cos A into 2 sin A cos A. Okay. Now this sin A cos A and sin A cos A can be cancelled. What we need? We need to get 2m in the right hand side. Here what is m? M is equal to sin A plus cos A. So we got sin A plus cos A. Okay. And we have a 2 here. We only cancelled sin A cos A. 2 is remaining, that is 2 sin A plus cos A. Sin A plus cos A is equal to m. Therefore, we get 2m. Okay. So we started with n into m square minus 1, and that is equal to 2m. Okay. So this is the required proof. Here we have the last problem for today, problem 7, question 7 of exercise 21B. If cos A by cos B is equal to m and cos A by sin B is equal to n, show that m square plus n square into cos square B is equal to n square. So we will be starting from this part, that is m square plus n square into cos square B is equal to, what is m? M is cos A divided by cos B. So m square is cos A by cos B whole square plus n is equal to cos A by sin B whole square. Okay. Into cos square B. Okay. Now this is equal to cos square A by cos square B plus cos square A by sin square B whole into cos square B. Now take the LCM. Here we have denominator cos square B and sin square B. Then the LCM will be sin square B cos square B Cross multiplying cos square A into sin square B is cos square A sin square B. Cos square A sin square B plus. Here again cross multiplying we have cos square A cos square B. Cos square B whole into cos square B. Now here we have a cos square B and this cos square B in the numerator can be cancelled. What is remaining? We have cos square A sin square B plus cos square A cos square B divided by sin square B. Now what is common in both these? Here cos square A is common to both. So taking cos square A outside, we have sin square B plus cos square B divided by sin square B. Sin square B plus cos square B. What do we get? Sin square B plus cos square B is equal to 1. Okay, using the identity. Sin square B plus cos square B is equal to 1. And that is cos square A into 1 divided by sin square B. Or this can be written as cos A by sin B whole square. What is cos A by sin B? Here cos A by sin B is equal to n. Okay. Cos A by cos B is equal to m and cos A by sin B is equal to n. So here we are getting n square. Okay. So we had to show m square plus n square into cos square B is equal to n square. We got m square plus n square into cos square B is equal to n square. Clear? That's all for today. In today's class, we have discussed many questions from exercise 21B. We have used all the concepts that we have studied in the previous class. That is the trigonometric ratios, relations of trigonometric ratios and also the trigonometric identities. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai par best hai. Thank you.